Alrighty. Yeah, so Greg Peranich here. I'm on the solutions engineering team here at Kong. And today what we're going to take a look at is building trust in a zero trust world, right? So a couple of great sessions here previously with both Vina and Eaton covering some of the different challenges that many organizations are facing out there from a security perspective, both from more of like categorical OWASP top 10 perspective, as well as some of the different vulnerabilities, right, that Eden and the team at Traceable have been able to find in many organizations out there like in the space, right? So today, what we're going to take a look at is what it takes from a Kong perspective to build an API security and governance framework, and then we're actually going to tie it into Kong API Gateway specifically and run through a few demos on how we can actually implement some of these security mechanisms, right? So first and foremost, when we think about building an API security and governance framework, right? Really, the idea is taking this idea of a top-down governance framework where you have a centralized team that is able to build out these patterns, right? And really prescribe to the different application development teams what is best practice for exposing a secure, reliable, and reasonably governed API, right? So we hear a lot of buzz terms being thrown around in this space, like zero trust security. And really what we're going to look at here today is how we can actually have different configurations in our stack that will allow us to secure things like the actual network. So like how development teams and other even maybe even bad actors like securing the network to where they're not going to have the easiest time of breaking in and actually stealing sensitive data, right? And on top of that, it's going to be establishing paradigms around authentication and authorization using standardizations. So a lot of folks there in the space are using OAuth 2 these days to help implement a security model, right? So when we think about this idea of building a unified security framework, really the name of the game is to gain consistent security, right? So we have that ability to actually directly affect what our application developers' experience are, when they're going to ship new features and functionality to the applications they're building, right? So the idea here is that if we have a standardized security framework and we make it pretty easy and really have a easily consumable way for developers to come in and instantiate new features and make sure that they're doing so in a way that's not increasing that vector for risk, then not only are we going to have a good security posture, but we're going to be able to iterate faster, right? As far as enabling these teams to actually build out additional capabilities, and shipping great features in the apps and services, right? So one way that we can think about doing that is, with this idea of building out a framework, building it out in such a way where you have reusable and shareable sets of policy that can be applied to any API that's being exposed, right? So when we think about a developer that's shipping a service, we want to make it super easy for them to take this idea of like a security pattern or policy and implement it directly in their CI/CD pipelines that allow them to drive those changes in declarative fashion, right? So one last thing we want to think about is, after taking this idea of implementing a finely grained security model and really driving that framework with application development teams, we also want to have a way to govern what's happening in our entire topology, right, within an organization of the API ecosystem itself. Right. So at a very high level, we're talking about observability. So when we think about observability, it can cover a number of different areas, all the way from kind of your basic, like we want to make sure we have in-depth logging for every single transaction that's coming through our API infrastructure, all the way down to some of the more granular insights. So when we think about the different observability signals that are out there, not just logs, but leveraging things like distributed tracing as well to have direct level insight to understand when a transaction comes through the system, what are all the different entities that's touching behind the scenes, right? So we hear about certain standardizations today. Something that's becoming super popular is leveraging the open telemetry standards to help propagate those distributed traces throughout a microservice oriented infrastructure. And that's really best practice. What we're seeing out there with many of our customers is they're using the API gateway to actually initialize those traces before the API request goes to those backend systems. So, why this is important and where this brings value, not only are you able to see what's happening right at the front door as somebody's trying to come in and consume an API, but you can actually go all the way down the stack and understand for each given transaction, what is that actually, that topology and that trace looking like for all of the entities that are being interacted with. So, uh, on top of leveraging these different signals from an observability perspective, we also like to think about the security insights that we can provide, uh, based on the collection of these different signals, right? So that means things like for my given APIs that might be exposed on the edge for my organization, what do those interactions look like? Who's actually coming in and consuming the APIs? Are the majority of these APIs, are they exposed, leveraging security, authentication, authorization, style policies? Are we seeing a spike in 401, 401 or 403 status codes or even 400s where payloads might be misconfigured? Having good security reporting on a API by API basis will help platform teams and application development teams understand, hey, for my subset of APIs that are exposed, not just how they're performing, but how are they performing in the sense of as related to our security posture. So I want to take this idea of building a security and governance framework and observability, right, and tie it into what we can do here at Kong. So what we're going to take a look at here is a few different areas at which we can implement this API security model and establish a governance over how we're going to expose an API. So the first thing we're going to take a look at is network security. So how we can fine tune our Kong API gateway configuration to actually implement strict governance over how we're exposing our software and our APIs to the world. We're then going to take a look at a couple of policies more in the security and like authentication authorization space, namely the OpenID Connect plugin and enhance zero trust security with threat protection policies we have here at Kong. And then finally, we're going to take a look at the output of that and see how we can leverage the platform to actually uh, obtain insights into not only how, like I said, how our APIs are performing, but also who's coming in using them, how often, are there security issues at play. So the first thing we'll look at here is network security in Kong, right? So as with pretty much any gateway out there in the market, table stakes are going to be to expose the proxy over secure ports and communication protocols, right? So with Kong, we have the ability to go in and finely tune some of the different parameters, right? So we can make sure that we're exposing these APIs only on secure ports and that we're handling things like SSL and TLS as it's coming into the gateway. So what's really interesting about the gateway is a few different ways we can actually set it up where we're either going to actually end up terminating the TLS at the gateway level and then reestablishing another TLS connection as we're proxying that request to the upstream. But we also have the ability to do end-to-end encryption. So if you have use cases where we need to have an encrypted connection all the way through the gateway, that can also be supported. And then getting it potentially even more granular level, mutual TLS is also a pretty popular standard that we see where we're enforcing clients to not just present authentication tokens for accessing APIs, but they actually need to come in with a dedicated certificate and secret key pair, right, that will allow them to actually establish that mutual TLS handshake whenever they're going in to consume an API. So when we think about the threats and risks that are mitigated here, it's really just mitigating that risk of insecure access and having data exposed in plain text over the wire, right? So that's targeting the use cases where you want to make sure that for every single API that you're exposing, you're making sure that those endpoints can only be accessed securely, right? And it brings some benefits, namely in the data security and privacy space, making sure that those connections are actually authenticated and you can actually trust that every single connection coming in is from a secure access point. And then, for many organizations that have to, fit into compliance concerns and regulatory requirements, it mitigates risk. So yeah, I threw a couple of examples in here, for our friends over on the European side of the pond, or with GDPR, or even here in the United States dealing with HIPAA regulations. Ensuring that the way that we're exposing our APIs and data is over these secure access points will help to give confidence when it comes time for audit or time to, satisfy these regulatory requirements that we're going to be covered, right? So tying this into Kong, I have a Kong gateway instance up and running here that we're gonna actually interact with over a very simple API. It's actually an Echo API, right? That's exposing, a transaction, like a similar to like a financial institution's transactions ledger. So the first thing we're gonna take a look at here is how we can configure the gateway instance to make sure that the ports and the TLS configuration that we have is gonna be as secure as possible. So the first thing I'm going to bring up here briefly on screen is my configuration for the gateway instance. So I'm actually running this gateway in a Kubernetes cluster. So what we're taking a look at is actually that manifest for the pod that's running the gateway and implementing it as the ingress point for the cluster. And what we can see here is that I've got a number of environment variables that are dedicated to how we're actually going to expose the actual Kong proxy instance itself, right? So here we can see that we have that ability to scope the ports that are actually going to be opened up and which protocols are going to be implemented on those ports. So we can see here for the proxy itself, we're actually only opening up port 8443, and it has to maintain an SSL protocol, for all connections coming in, right? And then we can also see that specifically for TLS connections, we're using a very specific client cert and key to establish that TLS protocol. And then we're also forcing that only SSL protocol connections that are coming in over TLS 1.2 and 1.3 will be accepted. So what that means, if I bring up Insomnia, which is our debugging tool supported here at Kong, and I try to consume my gateway instance that I'm running over an HTTP protocol, I actually won't even be able to connect to the server, right? Whereas if I go and try to consume it over HTTPS, which is hitting that port 8443, we'll actually be able to go in and hit our API. So now that we've looked at the actual implementation of the gateway proxy, right, and how we can ensure that those access points are secure, the next thing we want to look at is how we can authenticate and authorize those transactions that are coming in. So, for this particular use case, what we're going to take a look at is our OpenID Connect plugin supported here at Kong. So the OpenID Connect plugin, allows for integration with third-party identity providers to be configured in a standardized way within Kong, and it's actually implementing Kong as a proxying OAuth 2 resource server, right? So the plugin itself supports several types of credentials and grants, most of which are supported there in the OAuth 2 standardization. And really what we're looking to mitigate here is a risk of unauthorized access. So we already have established a secure port. Now we want to make sure whoever's coming in over that secure access point is both authenticated and authorized to consume the APIs that we're exposing. We see this useful in a few different use cases, right? So if we think about applications that might be exposing a user interface, a common practice here is actually putting a gateway in front of the actual user interface and leveraging the gateway to actually handle single sign-on, so you can implement both authentication and authorization in conjunction with identity provider. We also see the use case there if you need to integrate with IDP, like so that being Okta, Azure AD, really any of the big brand name identity providers out there that expose OAuth 2 frameworks. It gives us that point where we can actually integrate the gateway with that particular identity provider and make sure that all of these connections are happening in a secure manner. So what we're going to take a look at here is actually how we can leverage the OpenID Connect plugin to actually enforce both an authentication and authorization security model for an API that we have exposed via the gateway. So to do that, what we're going to take a look at, I'm actually going to go and grab my proxy endpoint. And I'm going to open an incognito tab here in Google Chrome just to make sure that I don't have any cookies or sessions present that will automatically authenticate me to the API. And we actually have this API, which is an Echo API, listening on an endpoint of Okta, right? So what we'll see is when we hit the Okta endpoint from the browser, Kong is actually going to handle the redirection of this API call, from the Kong entity itself to Okta. So as a user, right, after I provide my username and password, and then go in and satisfy the multi-factor, we'll see that Okta is actually going to redirect this request back to Kong. So this is a standard, three-step auth 2, flow, commonly known as an authorization code flow. So what you'll see here is something super interesting. So we've gained access, right, to the API in the sense that I am a valid user. I've been authenticated with Okta. I'm permitted, to be redirected back to, the Kong Gateway proxy here. But we'll see that we're actually getting a 403 forbidden message. And the reason behind this is because with our OpenID Connect plugin, we not only are integrating with the IDP to actually, drive these OAuth 2 authentication, flows, but we can actually take that resulting JWT bearer access token and have a look at the claims that are present in that token that's being issued by the identity provider to drive authorizations, right? So what I'm gonna do now is, come over to Kong Konnect, which is our control plane for the gateway that I'm managing here, for the demonstration. And what we're going to take a look at is the OpenID Connect, plugin configuration that I have exposed on this API. So if I come over to my endpoint here, and we'll see that we have the OpenID Connect plugin installed. And we'll see here that we have, this integration set up with Okta, right? So what I just demonstrated was the authorization code flow. But again, one thing to call out is the OpenID Connect plugin can actually implement not just authorization code flow, but can also drive client credential grant flows, just verifying JWT bearer access tokens that are coming in, OAuth 2 introspection, and it can even issue and manage session cookies as well. So what we'll see here in the plugin configuration, right? So if we come to the authorization tab, there's a number of different claims that we can actually provide authorization over, including scopes, audience, roles, and in this case, for my plugin configuration, groups, right? So in this particular case, I'm saying for the groups claim that's coming back in our JWT access token from Okta, we want to ensure that there's a group in that groups array of the claims that's called team sales engineers. Now, I happen to know this is a typo. I'm not actually a part of team sales engineers group in Okta, but rather team sales engineering. So what we'll see here is after I go and update this authorization to include the group that I know that I'm a part of, that I should be able to both authenticate and be authorized to access the given API that we're hitting there in the incognito window. All right. So I've saved that change. And as that configuration is propagated to our gateway instance, what we'll see is that I now have the ability to both authenticate and authorize to consume that Echo API. So to quickly summarize there, that OpenID Connect plugin can be super useful, and it's actually one of the more popular enterprise plugins we have here at Kong because it takes a somewhat complex flow, which is integrating with an IDP to drive these different types of authentication and authorizations. It makes it super simple for dev teams to and platform teams to actually build out security patterns and ship them off to their development teams that they can really just implement without having to write any code. So the next thing I want to look at is, now that we have a transaction that is happening over a secure access point, via the network that is authenticated and authorized, we also want to add some enhanced zero trust protections to make sure that the content of the request itself conforms to the standards, of the API that we're shipping, right? So for this, what we're going to take a look at is one quick example is what we call the JSON Threat Protection plugin. And what this plugin does is it validates and protects against malicious or overly complex JSON payloads. So with that, we can think that it's there to mitigate JSON-based injection attacks, perhaps oversized payload attacks that are targeting denial of service type bad actors coming in, and even malformed JSON, which can degrade performance, but and also lead to issues within that upstream application. So we see this used a lot with public APIs that are deployed at the edge where there is user submitted data. So with that, you could think post request, patch request, put requests, right? And then high trafficked APIs that are vulnerable against not just DDoS attacks, but also denial of service attacks via those large payloads. So with this plugin, what we have the ability to do is actually prevent that performance degradation, and we can ensure that we're shipping a stable API, right? So to showcase what's going on here, I'm going to jump back into Kong Konnect. And that original account transactions API that we're hitting, yeah, we could see the endpoint that we've configured here. Now, on this given endpoint for our account transactions API, we'll see that we have a couple of plugins implemented. So we talked through OpenID Connect and how we can drive authorization code flow. For this particular API that we're actually hitting there from Insomnia, we're requiring a JWT bearer token to be present. So we're actually integrating with Okta here to ensure that the transaction that's coming in is valid, presenting a valid token and has valid, claims that are being passed for me to be able to consume the API. What you can also see here is that we have a JSON Threat Protection plugin implemented on this given API, right? So with the JSON Threat Protection plugin, you can see we have a few different things configured. In this particular case, again, for the purpose of this demo, we've configured specifically that if we're passing an array in the JSON body, we want the max element count that can be present in that particular array to be 3 elements. So this is protecting against denial of service attack where a bad actor might submit a request that has a million different elements in that JSON payload, right? We're also limiting the number of entries into the JSON object itself to 7 different properties. So we know quite specifically what the upstream application is expecting from an argument perspective on the objects being submitted in via that JSON payload. So we have the ability to configure a maximum number of entries that we're expecting in that object that's being submitted, right? So what that means in practice is if I come back over to Insomnia now, what we'll see is if I'm hitting that API over the HTTPS endpoint with the correct and expected payload, that we're getting a successful response from our upstream API. But let's say that I wanted to add another element, right? Another property to the JSON payload that's being submitted. Just add a simple testing true. What this is going to take it to is actually 8 properties that are configured in this payload that I'm sending along to the API. We'll see that we'll instantly get a 400 bad request because it doesn't conform to the policy that's been configured there in our JSON threat protection plugin. Likewise, let's say I have the correct number of properties that are configured for this base object in the JSON payload, but let's say I'm sending one too many transactions. So what we'll do is we'll just add a 4th transaction here. And again, send the request and see that we're going to get that same 400 bad request coming back from the gateway, right? So even though this is an API that's connecting over a secure access point and port, and even though that we're both authenticated and authorized to actually consume the transaction, even like as a bad actor, if I have the ability to do all of this, right, we're still validating that actual payload that's being submitted to ensure that we are offering a reliable service and we're not going to be subjecting ourselves to the risks of a denial of service attack. So the last thing we want to look at here, now that we, again, have explored how to secure our APIs that we're exposing, is the observability angle, right? So there's a few different things that we want to take a look at here and leverage observability in our system to understand. First and foremost, we want to take a look at uh, threat detection and how we can respond to incidences, right? So the idea is for all the APIs we have exposed by the platform, which ones are experiencing the most 4xx status codes, for example, which ones are you're rejecting requests for the most bad authentication credentials, improper authorization, via the people that are actually coming in and making their requests, and even bad or malformatted payloads that are being sent across through the gateway trying to target the upstream APIs. We can also use the observability system here to make sure that we're maintaining compliance and auditability. So not just information about those requests that are coming through the system, but also who's coming in and making the request. We want to make sure that it's authorized actors that are coming in. And then even if, let's say, we're shipping these APIs just to other internal teams, we want to have that confidence that whoever's coming in is authorized to consume the transactions. And if we want to get into the business of, say, charging for usage, within the organization, we have that topology of who's coming in and making a request against given, the given APIs that are exposed, right? So with that, what we're actually going to explore here is another feature in Kong Connect, which is Connect Analytics, right? So far I've been living in the Gateway Manager capability in Connect, which allows me to manage distributed deployments of Kong Gateway instances, so the actual API configuration itself. With the analytics capability in Connect, what it gives us the ability to do is actually maintain oversight and governance over all of those gateways that are deployed and our entire topology of APIs that are exposed via the Kong gateway instances. So in this particular case, what it gives us the ability to do is explore those usage insights and generate reports. So for this particular example, we have our Kong security report here, and what we want to take a look at is the top gateway services that are being hit with 4xx status codes, right? So with this, over the given time period, which is the past week or so, we could see out of all the services that are being exposed by our gateway instance, which ones have, potentially have the most bad actors coming in and trying to gain unauthorized access, to those specific services. So what's pretty interesting is, while we see the total number of services that are, exhibiting and producing these 4xx status codes, we can use the analytics capability here to dive even deeper and understand, okay, for each one of these services, I don't want to just see, which ones are, shipping the 4xx status codes. We actually want to break it down by status code as well. So Connect Analytics gives a lot of flexibility where you can filter down those transactions, based on the target group that you're wanting to see and gain those granular insights, right, into, what the behavior and performance is of these specific transactions. So that's one such example. Another report we can take a look at is the actual API usage by consumer. So, for this particular case, we're seeing over the past 24 hours, who are the top consumers that are coming in and actually accessing these APIs of the platform. So we have the ability to maintain consumer identities, within the Connect platform here. So we're able to see things like the named consumer that's coming in if we've established their identity. And if not, we can see information about like the actual authentication credential, that's coming in and being presented to actually access these APIs. So with the combination of the security report, where we can see how the APIs are performing against our security model, as well as understanding who's coming in and actually making these requests, we can ensure that not only do we have a secure platform, but we have a line of sight into governing who's actually coming in and how they're actually interacting with the APIs that are being exposed by all of our application teams. So that's all I had to share there today. I know we have about 10 to 15 minutes left in the session here. So, Caitlin, can definitely leave this up on screen if we want to open up for questions that I think that could be in scope as well.